Conversion of galvanometer into ammeter, and these are 3 mark questions. Conversion of galvanometer into voltmeter is also there, and this is conversion of galvanometer to ammeter. First of all, what is ammeter? An ammeter is a device used for the measurement of current through the circuit. Hence, it must be connected in series with the circuit. Suppose I have a random circuit here, some random circuit, some of the devices were connected in it. I want to check the amount of current in it. I want to measure the current in it. In this particular circuit, how much current is flowing. For that, what we need to do, we have to connect a device, current meter, that is called as ammeter. That should be always connected in series with the circuit. Therefore, it should be connected in series. The current will flow in the ammeter and it detects the current in it. But the introduction of this ammeter should not alter the current in the circuit. Hence, it must have very low resistance. The resistance of ammeter should be very low. If resistance is high, what happens? It alters the current in it. That should not happen. That is why the resistance should be maintained very low in an ammeter. But our aim is here conversion of galvanometer to ammeter. We can convert it. Why we need to convert? Sometimes in our lab, maybe the galvanometer only is available, but there is no ammeter with us. That time the galvanometer only can be used as ammeter. That is possible. But how it is possible? Because generally the galvanometer what we have has not very low resistance. Its resistance is not very low. It cannot be directly used as an ammeter. Its resistance can be made low. We can make it low by connecting a suitable resistance in parallel with the circuit. So we can connect this particular galvanometer in our lab. It has high resistance compared to the ammeter, so we cannot be used directly as an ammeter. So overall resistance of the galvanometer should be reduced. How to reduce it? By connecting a shunt resistance in it. Shunt resistance means parallel resistance should be connected with the galvanometer. Then the overall resistance of this system reduces, and this system can be used as an ammeter. Now we can replace this ammeter and we can connect this converted ammeter. Galvanometer is connected now as an ammeter. So this system acts as an ammeter. So that's what here it is given in a figure. But what we need to write in the exam. So this point, the galvanometer can be converted into ammeter by connecting very small resistance in parallel with it. So that's what you are observing in a diagram. So there is a galvanometer here, and we connect a resistor which is very small value in parallel with the galvanometer. Then this system acts as an ammeter. Okay. What is G here? G is called as the resistance of the galvanometer, and the current here I is coming. The main current, I can call the main current which is coming. Once it reaches a junction, it takes two paths. Some of the current goes into the galvanometer, and remaining current, that is I minus Ig, will go into the resistor S. So Ig is the current with which the galvanometer gives a full scale deflection. If Ig flows through a galvanometer, it completely shows a deflection, complete deflection. So the needle should be at the end of the galvanometer. And S means shunt resistance we are using. So I here the current required, the required current range of the ammeter. So how much current we want to measure? That current is I here. That is I. We are measuring this much current in a circuit. But here you can see the circuit diagram. These two devices, that is galvanometer resistance, or simply consider it as a resistor, and this is one more resistor, are in parallel. If two resistors are in parallel, then the voltage across both of them is same. So the potential difference or voltage across the galvanometer is same as the potential difference across the shunt resistance. So how much voltage you are applying at the ends, the same voltage is applicable for both G as well as S. Therefore, I will write here one step. So potential difference across the galvanometer should be equal to the potential difference across the resistance S. But apply Ohm's law now. So according to Ohm's law, V is equal to IR, right? V is equal to IR, current into resistance. So VG is voltage across the galvanometer, that is equal to current through a galvanometer multiplied by resistance of a galvanometer. Ig into G, Ig into G, that is equal to Vs, the voltage across the resistor, that is current through a resistor multiplied by the resistance of that resistor. So I minus Ig is the current which is passing through the resistance. You can see I minus Ig is flowing through this resistance. Therefore I minus Ig into S we are going to take. Now the shunt resistance to be connected can be calculated by using this formula. S is equal to Ig divided by I minus Ig into G. So this much shunt resistance or parallel resistance should be connected in parallel with the galvanometer. Then our galvanometer acts as an ammeter of desired range. How much current it can be measured? We can use that much ammeter value. So by connecting a shunt resistance S across the given galvanometer, we get an ammeter of desired range. This is 3-mark question. And next one is there, last one. Conversion of galvanometer into voltmeter. This is also for 3-mark. So conversion of galvanometer to voltmeter, G to V. Before that, what is voltmeter? A voltmeter is a device used to measure the potential difference between the 2 points in a circuit. Hence, it must be connected in parallel with the circuit. Suppose I have a circuit, the same circuit I can copy it. Suppose I have a circuit here. Already I used the circuit, correct? I will just copy it. But I want to calculate now the potential difference across the circuit. I will cut it and I will paste it here. Okay, this is the circuit I have. Now I want to calculate, I will make it closed circuit. The current is passing in it. Now I want to calculate the voltage or potential difference across the resistor. So the current is always through the resistor, but potential difference is always across the resistor. So across means we need to connect the voltmeter always in parallel with the circuit across the resistor here. Then this voltmeter will measure the voltage across the resistor. Okay, to be connected in parallel with the circuit like this. The voltmeter should not draw the current. This voltmeter is there here. It should not draw the current, because whenever it draws the current, what happens? The current will be altered in it. The current will be altered in the circuit, so it should not draw the current. When it will not draw any current in it, we have to maintain the voltmeter having a high resistance. So voltmeter used here should have very high resistance so that the current will not flow in it. So very high resistance should be maintained. But in our lab, voltmeter is not there, but only the galvanometer is there. Then this galvanometer can be used as an voltmeter. But generally, the galvanometer resistor is not very high. The galvanometer in our lab have resistance is not very high. Hence, it cannot be directly used as voltmeter. But its resistance can be made high by connecting a series resistor with it. If you connect a series resistance, some high value resistance in series with the galvanometer, then this system has higher resistance, and this system can be used as voltmeter. Then it can measure the voltage across the resistor. Now we can replace this and we can connect this system to the converted voltmeter like this. It can measure the voltage of desired range. So for 3 mark, you need to write first to this point. The galvanometer can be converted into voltmeter by connecting a large resistance in series with it. So this point is important, and later you have to draw the circuit diagram. So resistor should be in series with the galvanometer and the current which is flowing in it. Very small current. Here G is the resistance of the galvanometer and Ig is the current with which the galvanometer gives a full scale deflection. And what is R here? R is very high resistors connected in series with the galvanometer. And here this is 0 to be the required current range of the voltmeter. This is voltage range. Now I will apply the Ohm's law. According to Ohm's law, the voltage across the circuit is equal to current, total current passed through the total resistors in a circuit. But what is the total resistance in a circuit? The total resistance, where G is the galvanometer resistance and R is the resistance to be connected to convert it as voltmeter. So total resistance is G plus R, right? So this is our total. I will write the current flowing through the circuit is Ig we have taken, and R total is G plus R. Therefore we'll solve for R. So how much R to be connected, we have to solve for that. So V divided by Ig is equal to G plus R. So R is equal to, next step you are going to get R is equal to V divided by Ig minus G. So this is the value of a resistance to be connected in series with a galvanometer to use it as voltmeter. So by connecting a high resistance R in series with a galvanometer, we get a voltmeter of desired range. So we can convert the given galvanometer as 3 volt voltmeter, 2 volt voltmeter, 5 volt voltmeter. That means the galvanometer Converted galvanometer measures maximum of 3 volt or maximum of 5 volt.